Okay, yes. In the yesterday class, they asked the question in from the previous question paper. I am sharing the screen. My screen is visible to all of you. Okay. Okay, fine. So here, this is a question. In this question, what it is asking, give epsilon. This is epsilon. Okay, epsilon NFA to accept 0 power n, 1 power n, 2 power n, and that should n should be greater than 0, and we need to find the e-closure of all states. So the question is how to prepare the state diagram and how to find the transition for this and how to find the e-closure. Okay, these are the things in it asked in the exam. Okay, 1 minute. Okay, so here, so what we need to do first, how we can read this 0 power n, 1 power n, and 2 power n, and that should be n greater than or equal to 0. So how can we read this we can read any number of zeros, any number of zeros followed by any number of ones followed by any number of ones, any any number of ones, okay, followed by any number of twos, followed by any number of twos. So for this kind of problem we cannot solve in the regular expression. This is not a regular expression, so it is not telling to do any operation, just it want the e-closure of states and with the epsilon. So just we can make the state diagram for this. Okay, let me just give me a second. Okay, no one is joined. Okay, fine. So here, first of all, here we will make a state diagram. What is a state diagram now? Like I will take this color. First, initial state, that is start, and I am taking one q0. Okay, I am taking q0, first one, and I am telling, it is telling any number of zeros. What it is telling? Any number of zeros. That means whenever we will get any number of zeros, that should be loop. Okay, and next it is telling about the epsilon. So here the next state will go with the help of epsilon, and here q1 bracket, and what it is telling? Any number of ones, any number of ones, that is epsilon is like a null, means it there should not be a 0 or 1. Without 0 and 1 it will go from q0 to q1 with the help of epsilon. Because of that, this is a epsilon NFA. In normal NFA we will not have epsilon. When we have epsilon, so that question, the change that will be changed to epsilon NFA. Okay, to move from q0 to q1 we are using the epsilon. That is, we can say null only, but with the help of epsilon we will solve the problem. Okay, next, from q1 to q2, q1 to q2, how it is going? With the help of epsilon, because we need to this condition should be satisfied, and with the help of this condition we need to make a state diagram. So what is this q2? q2 is any number of 2's, any number of 2's. Okay, and here 1 2 3 like this, here we are completing our state diagram. So this is our final state. Whenever you are drawing the state diagram or transition diagram, the name of this is transition diagram or state diagram, state or transition diagram. Okay, and this video I am going to upload on the YouTube also. Okay, so here we draw the state diagram for the given condition. Okay, for the given condition we draw the state diagram. Now here we need to know how many are there with the epsilon transition. Means from q2 q0 to q1 is going with epsilon, q1 to q2 is going to with the help of epsilon. So this is epsilon closure. Okay, E closure is nothing but epsilon closure of all state. For all the state we need to find the epsilon closure. So here okay, so now here we need to go with the main thing. M is equals to, here what is the NFA syntax? Sorry, what is the syntax? Means how many q states are there here? 1 2 3. So what is the, here is q and sigma, delta, q0 and f. So this is we need to find in the NFA. In the NFA we need to find q0, sigma, delta, q0, f from the state diagram. Okay, can anyone tell me what is q here in this state diagram? Can anyone? Hello. Okay, no problem. In the q is q0, someone is misses something, 0 1 2. No, q is q0, q1, q2. How many states are there? Okay, second one, sigma. What is sigma? Sigma is input symbol. What are the input symbol? 0 1 2. Input symbol we have 0 1 2. Okay, now what is q? I will tell you about this. What is q0? Q0 is initial state. What is initial state? We have q0. Next one is f. F is a final state. So which one is a final state? q2. Okay, now we need to solve this one. If I go down here, now first of all I need to find the E closure of, means epsilon closure of q0. What is this epsilon closure? That means, sorry, that is in the state diagram, from the q0, how many state is reaching from the q0? From q0 to q1, and as well as we can say q0 to q2 also. So the answer is, whenever we have the epsilon NFA, so you can say like this will also a epsilon by itself also, but we need no need to represent this, okay, but by default it will be loop. Okay, the next one is E closure of q0 is, first one is q0 itself, the next it's going to q1 with the help of epsilon, and q2. So here q0, q1, q2, these three states are there. It's going from q0 with the help of epsilon. Okay, now what is the E closure of, what is the E epsilon closure of q1? What does it mean? E closure of q1 means from the q1 with the help of epsilon where it is going. So by default by itself, okay, so there that will be the q1 by itself. The next one is going from q1 to q2 with the help of epsilon, that is q2. Okay, the next one is last one, E closure, epsilon closure of q2. It does not have anything, so this is the final state. So by default by itself we can consider only, okay, by itself with the help of epsilon it's go by itself q2. So the first one is q0, q1, q2, that is E epsilon closure of q0, epsilon closure of q1, epsilon closure of q2. We got it. Okay, now we need to find transition function is to calculate. We need to do the transaction function is calculated. How to do that I will show you. Okay, till now everyone is clear? Sorry. So here with this problem, okay, 0 power n, 1 power n, 2 power n, without using the Turing machine, we are using the epsilon NFA. We make a state diagram, and in the state diagram what are the things? Tuples. How many tuples are there? 5 tuples. Okay, this is called tuples. 5 tuples are there, q, capital Q, sigma, delta, q0, f. From this state diagram we define what are the things are here. Now we need to calculate the transaction. So how? This is first one, delta dash q0 comma epsilon. First of all we need to check q0 of epsilon where it is going. So what is the answer? The same answer we will get, epsilon closure of q0. Whatever the answer of the epsilon closure q0, the same answer for the q0 comma epsilon. Okay, what is the answer? Answer is this: q0, q1, q2. Okay, next, delta q0 comma 1. Sorry, first we need to do the 0. So what is this? Epsilon closure, closure, closure. What is the answer for this? We need to find delta q naught, because I have this value q naught comma epsilon comma 0. In place of this q0, okay, delta q0 comma 0, so in place of q0 comma epsilon, this value I want to add here. Okay, so here next step is epsilon closure, we need to substitute. Okay, epsilon closure delta, what is this q0 comma epsilon here? Because what we are telling here, q0 comma epsilon is the answer of E closure of q0. What is the answer of E closure of q0? E closure of q0, the answer is q0, q1, q2. Okay, so here the answer is q0, q1, q2. Okay, comma this 0 as it is. Okay, next, what is this epsilon closure of q0? What is epsilon closure q0? The same answer we will get q0, q1, q2. Okay, so what is the answer? q0, q1, q2. Means when we have q0 comma 0, at that time it will reach to q0, q1, q2. Okay, so this is first thing, we find the lambda dash q0 comma 0. In the same way, we need to solve delta lambda q0 comma 1, because we have 0 1 2. Okay, 0 1 2. So first q0 comma 0, the next is q0 comma 1. So here E closure, the same thing we need to write E closure. What is the E closure? Same thing, whatever we have previous one, delta q0 epsilon, but here the comma 1. Here the comma is 1. Okay, next one is, what will be the answer for this? E closure means epsilon closure delta, what is the q0 comma epsilon value at the top? E closure of this one, q0 comma, very good. So here We need to come back here. Here we need to write Q0, Q1, Q2, and this should be in the flower bracket. Okay, next, what is the remaining here is 1. Now what is the Q0 means, here we completed the Q0. Now here we need to do the epsilon closure Q1. So what is the Q1? Epsilon closure of Q1 at the top is epsilon closure Q1 is Q1 comma Q2. Q1 comma Q2. What is the answer? Q1 comma Q2. Okay, in the same way we need to solve delta, sorry, I am telling delta, it is a lambda, sorry, delta Q0 comma 2. Okay, like this if we solve, I am not solving now, the same procedure you need to follow. Here you will get the answer Q2. Okay, directly I am writing the answer. The same procedure what we followed to Q0 comma 0, Q0 comma 1, Q0 comma 2. Okay, next one is same thing we need to do, but we need to do for, till now we completed to Q0. Now delta Q1 comma 0, first Q1 comma 0. So what the answer will get for this, we need to follow the same procedure. If you follow, okay, one I will show, then I will do that. So here what will be the answer for Q1 comma 0 is, if we go with the epsilon closure delta dash Q1 comma epsilon 0. We need to know about the value of the Q1 comma epsilon here. So here E closure this delta, and what is this Q1 comma epsilon? What is Q1 comma epsilon? Very good, Q1 Q2 here. So like this Q0 comma epsilon is telling E closure of Q0. In the same way we need to do Q1 comma epsilon is Q1 comma Q2. Q1 comma Q2. Q1 comma Q2 comma 0. Okay, so what is E closure of, because here Q1 Q2, but in the 0 state we don't have anything, so here phi empty. So the first Q1 comma 0 is a empty phi. Okay, we will say empty or phi. In the same way we need to solve, only 5 minutes are remaining. Delta Q1 comma 1, we need to find the answer for this. We will get the answer for this is Q1 comma Q2. Q1 comma Q2. In the same way, this all are the dashes. Q1 comma 2, the answer is only Q2. Whatever the E closure of Q2, the same answer will be reflect here. Okay, because it's told you to do all the transaction, so we are doing all the transactions here. Okay, here delta, sorry, we'll change the color. Now we are changing delta Q0, sorry, Q2 comma 0. The same procedure you need to follow. Here we will get the phi because only Q2 has the Q2 state is a E closure. Okay, so Q2 comma 1 also we will get the phi because empty, and delta Q2 comma 2 we will get the value Q2, the same value of E closure of Q2. Here I will make a table, then it will be finished in the 3 minutes. So here we need to make a table, transition table. First we will have a state, and here we will have the input state, and how many, 1 0 1 2, and what is this, input symbol. And here fine, 1 2, and here the states. Okay, we will say state. How many state we have? 3. I will change the color here. Q0, Q1, Q2. Okay, which one is the initial state? This one. And let me solve, then we will see the final state. Here we will get what is Q0 on 0, what we are getting in the top. If we go, yes, here what we are getting on the Q0 on 0, what value we are getting? Q0, Q1, Q2. Okay, we need to check in the top and we need to fill the table. So Q0, Q1, Q2. Okay, this is a state from Q0 to 0. And what is Q0 to 1? Q1, Q2. You need to make a flower bracket. I make a table, small table, Q2, sorry, that is Q2. I will reduce the size otherwise. Here Q1, what will be the Q1? Q1 on 0 is phi. What we got? We got the phi. And here Q1 comma Q2, and what will be the last? Same thing, Q2. Okay, now here from Q2 to 0 is phi. Here Q2 to 0 is phi, then Q2 to 1 is also we got the answer phi. Q2 to 2 is Q2. So here we need to see which one is the final state. Here we have the final state is, with the red color I will mark this one. Okay, this one is the final state, but you can see this Q2 is present in all Q0, Q1, Q2. So that means here all are the final states. If in any state